we are still working with slope, introducing two new ways of finding slope, not necessarily given the equation. So let's just look and do a quick refresher. So if I had this line and I identified that these 2 points were definitely on that line, so that looks like the point 3, 2, and this is the point 8, 5. So to get from this red point to the blue point, it looks like we would go up, that's rise, 1, 2, 3. So we would go up 3, that's positive 3, and to the right, that's positive 1, 2, 3, 4, 5. So that slope would be positive 3/5, keeping in mind that that line contained the point 3, 2, and 8, 5. So now we're going to work with another way to find slope given just the 2 points. We know that slope is rise over run. So another way that we could say that is we're taking the change in the y values, that's the rise, over the change in the x values, which is the run. So essentially, when we have 2 points, and we'll call them x1, y1, and x2, y2, to find the slope of the line that contains those 2 points, we would just take the difference in the y's, so we would write that as y2 minus y1 over the difference in the x's, which we would write as x2 minus x1. So we're going to use this equation when we are given 2 ordered pairs, an x1, y1, and an x2, y2. So let's look at that last example where we had the 2 points that were on that line, 3, 2, and 8, 5. And so I'm going to choose my first point to be the ordered pair 3, 2, x1, y1, and then the x2, y2 is going to be 8, 5. So if we wanted to find that slope, we would plug those points into our slope formula. So we'd start by saying it's y2 minus y1, 5 minus 2, over x2 minus x1, 8 minus 3. And that would simplify, 5 minus 2 is 3, 8 minus 3 is 5, to 3/5. Let's do another example. What if we were asked to find the slope of this line that contains these 2 ordered pairs, 1, 7, and 4, negative 8? We would first start off by just defining or identifying that one of those ordered pairs is going to represent x1, y1, the other x2, y2. And then we go back to our formula and we plug them in. It helps to define them so that you use the same y with its same corresponding x, so that when we write y2 minus y1, we have negative 8 minus 7 over, and then we have to use the x2 first. x2 minus x1, so we have 4 minus 1. And then we simplify that, and we get negative 15 over 3, which we then reduce. We always reduce to simplest form, and that gives us a slope of 5. Here we have 2 more examples, and we're still using our y2 minus y1 over x2 minus x1 to find the slope. But this is what these look like. We would plug it into our slope equation, and we would have that our m equals this. Notice that a negative times a negative is a positive. So that's actually negative 2 plus 2, which simplifies to 0 over negative 9, which is 0. So this slope has a slope of 0, which means we know that's a horizontal line. Whereas in our second example, we would define those as our x1, y1, x2, y2, and when we plug that into our slope equation, we end up with 7 minus 1 over 4 minus 4, which gives us 6 over 0. So that tells us that we have an undefined slope. We can't divide by 0. That's a vertical line. Lastly, you will have questions that instead of an ordered pair, they give you a table of values. You pretty much just have choices then. So if we're looking for the slope of the line, that has these given coordinates on it. We just need to choose 2 points that are on that line. I would go with the easiest values to work with. I'm going to choose these. And I know this is telling me when x is 3, my y is -6. Also, when x is 15, my y is 2. So next, we would define both of those ordered pairs as x1, y1, x2, y2. And then we put it in our slope formula. So it looks like this: y2 minus y1 over x2 minus x1, which then simplifies to 2 plus 6 over 15 minus 3, which then gives us 8/12. We can simplify that to 2/3, since 4 goes into both. So this slope is 2/3. And if we had chosen any of those other two, or any other 2 points that were on that table, we would still get a slope of 2/3.